This week I'm going to be sharing with us about layer 2s, basically. Very popular term in Web3 and blockchain space generally, but not so many people understand the concept.
So you all agree with me that blockchain is an amazing technology, taking Ethereum into case study, but there's a very big problem that blockchains face, which is a trilemma problem.
We've not found a single blockchain that can solve all three. The first one is the problem of decentralization, security, and scalability.
The characteristics of a full blockchain is it must be secured, decentralized, and also be scalable.
Ethereum, as we all know, has been able to solve the problem of decentralization and security, but is not very scalable. Herein comes the birth of layer 2 solutions.
Layer 2 solutions are solutions that are built on the layer 1. When I say layer 1, I'm talking about the base blockchain, like Ethereum and Bitcoin.
So it's just like saying you have a layer 1 and you built a solution, you build a protocol on top of it. So these solutions, this technology, these protocols, they are meant to address problem on layer 1.
So basically layer 1s are just Ethereum, Bitcoin.
Basically, layer solutions are blockchain-based solutions that help Ethereum to scale. Basically, there are many different types. We have one of the very popular L2s, Polygon, which is a side chain. We have optimistic Ethereum, which is an optimistic rollup. We have many others. We have Vera chains. We have zero knowledge.
We have two types of layer 2 solutions. We have the optimistic rollups and the ZK rollups.
What rollups do is they bundle up transaction and then they submit the finality to the main network, to the layer 1.
So optimism rollups basically allow smart contract to be executed off-chain, while zero knowledge allow privacy, improve the privacy when transaction is being verified without revealing any sensitive data.
How it does that is that it's kind of like abstracts requests, and it's like an abstract network that receives requests as well, and then batches it up using either zero knowledge or optimistic rollups. So, and then later on sends it to the layer 1 solutions.
So first and foremost, when you run a transaction in Starknet, it first goes through the sequencer. So the sequencer just groups all the transactions, batch them together. They can batch as many transactions, thousands of transactions as possible. So after it batches these transactions through the sequencer sends these transactions to the prover. The prover then generates a proof in the layer 2, and then it sends that proof to a smart contract in the layer 1, which is Ethereum. And then this smart contract in layer 1 is called a verifier contract. So it verifies that proofs really exist in the layer 2. After it verifies that, then it saves the information in the Starknet core contract in Ethereum layer 1. So this is how Starknets are able to achieve scalability.